Thus, material emit energy in the form of electromagnetic waves due to changes in the electronic configurations of atoms or molecules. For your information, the transfer of heat by radiation does not require the presence of an intervening medium. It is the fastest and it suffers no reduction in a vacuum. This is how the energy of the sun reaches the earth. We are interested in thermal radiation, which is the form of radiation emitted by bodies because of their temperatures. All bodies at a temperature above absolute zero emit thermal radiation. Radiation is a volumetric phenomenon, and all solids, liquids, and gases emit, absorb, or transmit radiation to varying degrees. However, radiation is usually considered to be a surface phenomenon for solids. The heat transfer rate by radiation can be determined using the rate equation given by the Stefan-Boltzmann law. The maximum rate of heat radiation is given here. Sigma is the Stefan-Boltzmann constant and the value is as illustrated. The idealized surface that emits radiation at the maximum rate is called the black body, and the radiation emitted by a black body is called black body radiation. Real surfaces emit radiation at a lower rate, represented by the given symbolic expression. Epsilon is the emissivity of the surface. It is a measure of how closely a surface approximates a black body. For the black body, epsilon equals 1. And for real surfaces, it lies between 0 and 1. Emissivities of various materials at room temperature are presented here. Based on the table, aluminium has the lowest emissivity while vegetation is the highest. Radiation incident is the radiation energy that falls on the surface of a body. Some of this incident energy is absorbed, while the body reflects the remaining energy. Black body will absorb the entire radiation incident. Opaque bodies will absorb some incident energy and reflect the remaining energy. The illustration shows the absorption of radiation incident on an opaque surface of absorptivity. The given equation gives the rate of incident radiation absorbed by the surface. Alpha is the absorptivity of the surface. It measures the fraction of the radiation energy incident on a surface absorbed by the surface. For a black body, alpha equals 1. Thus, it absorbs all the radiation incidence. For opaque surfaces, alpha lies between 0 and 1. Kirchhoff's law states that the emissivity and the absorptivity of a surface at a temperature and wavelength are equal. Net radiation heat transfer is defined as the difference between the rates of radiation emitted by the surface and the radiation absorbed. If the radiation absorption rate is greater than the rate of radiation emission, the surface is said to be gaining energy from radiation. Otherwise, the surface is said to be losing energy by radiation.